chapter 6 has been uploaded into your Google Classroom. Lepas ni saya akan upload semualah you all punya lecture notes. Tak perlulah by week untuk you all punya lecture notes kan. Okay, so I hope you have gone through a bit lah roughly but for your chapter 5 food and acidity. pH and acidity. Chapter 5 is about pH and acidity. Supposing bila you all punya test 1 Aku lupa dah. Test 1 you all. Do you remember?
Google tu week 7 rasanya.
Week 7 sekejap.
Apa jenis?
Sebab I takut nanti. Sebab I takut nanti syok-syok bagi you all test, bagi you all lecture pun sebenarnya lupa dah. Okay, so you all punya supposed to be on week 7. Week 7 tu this week ke?
Ada tu lagi 2 minggu madam.
Dan kenapa kita dah habis sampai pH and acidity? Kenapa kita dah masuk pH and acidity? Oh my god. Alamak. I takut nanti korang AD marah I cepat sangat pula daripada semua orang. Kita dah sampai pH and acidity. Tak apalah, habis lagi cepat lagi bagus kan sebenarnya. Okay. So sekarang minggu ke-5 Now is week 5, is it?
Yes.
So,
Ya, madam.
Minggu ke-5. Do you have any idea you all punya kawan yang group lain dia all pun sama macam kita ke? Ke dia all still belum habis lagi?
Tak tahulah madam.
Tak tahu, so you all tahu I tahu cakap madam. Bagus. Tak apa. So kita proceed je. Alamak, I risau juga kalau laju sangat nanti korang marah pula AD dengan I. Tapi tak apalah, kita proceed je lah Okay, so for today we are going to start off with pH and acidity. Okay, pH and acidity, this one basically it is referring to two different methods. Kejap. Allah. Siapa yang baru nak join ni? Aish. Okay, so when we talk about pH and acidity, we are talking about another two more students. Okay, we are talking about two different methods, okay? pH, how do we measure pH? One is by using pH meter. Okay, pH is pH. pH is not reflecting towards the acidity, total acidity inside of a particular food. Okay, so pH, when we talk about pH, maksudnya kita buat measurement of pH by using pH meter. Ataupun kalau kita ada a strip, a test strip untuk check pH, bukan litmus paper this one untuk test strip ni memang dia akan bagi colour according to the pH of a certain material. Contohnya, for example, if you are talking about chlorinated water, air yang ada chlorine, okay? So we have the test strip untuk chlorinated solution. So this particular test strip, kita akan koyakkan. This one kalau you join nanti food industry, you are going to deal with this particular test strip, okay? Test strip, STRIPS. This particular test strip ni, you koyakkan sikit dan you akan submerge dekat dalam solution yang you nak measure tu. Nanti bila you keluarkan that particular test strip, dia akan bagi you different colour. So according to which pH yang you nak. So test strip tu dia akan ada reference of colour. Contohnya kalau macam the test strip, the colour is green, what is the pH? Kalau colour dia merah, what is the pH of that particular solution? Okay, and then when we talk about acidity, basically acidity is by measuring total titratable acidity. This one by performing titration. Titration contohnya you ada a flask with a fruit drink. Contohnya macam orange juice. Okay, kita nak tahu berapa acidity dalam orange juice tu, kita akan perform titration. Okay, dalam burette tu, have you performed titration before?
Yes.
Titration. Okay, bagus. Titration pakai yang burette tu kan? Kan ada burette tu. So dalam burette tu ada sodium hydroxide, kita nak neutralize the solution. Jadi volume sodium hydroxide tu, how much volume of sodium hydroxide is able to neutralize your solution in the flask, yang itu akan ada calculation. That one will representing total titratable acidity. Okay, so ada dua lah. Jadi jangan confuse when we talk about pH. pH is not reflecting the total titratable acidity of a certain food material. Alright, so now we move on to chapter learning outcome. Okay, before this I pernah tanya you all pernah guna pH meter tak? Some of you answer tak pernah. Tak pernah pakai ke yang pH meter yang probe tu untuk check pH solution?
Tak.
Tak pernah madam.
Pernah.
Masa SEM 1, SEM 2 kan ada kena ambil chemistry kan? Tak buat Tak apalah nanti.
Tak, kesian kita.
Tak apalah, nanti boleh tengok dekat YouTube macam mana nak measure pH pakai pH meter. But basically it's a very simple procedure. You ada probe. Probe tu macam pen ni lah. Okay, you ada probe. Of course you ada yang digital punya display, digital display. You masuk je probe tu dalam solution, dalam air ke, dalam orange juice ke contoh. Then you tekan read. Nanti digital tu dia akan bagilah what is the pH of that particular solution. Okay, tapi sebelum very simple je, macam tu je pakai pH meter. Sebelum nak pakai pH meter tu, probe tu you kena rinse dulu dengan distilled water. Dah rinse, lap sikit dengan a good quality of tissue because you do not want to scratch that particular probe because probe is very expensive. Dan lepas tu masuk dalam solution yang ada beaker yang dalam ada air tu, solution ke apa ke, masukkan, submerge, and then tekan read. So you dapat the value of pH for that particular solution. Very simple je, tak susah pun. It does not require special technique for you to know how to check pH by using pH meter. Tapi I rasa lega lah because you have your experience to perform titration. Tapi itulah, saya pun kalau boleh sebenarnya I want to show you the correct method of how to do titration because you need to use your finger in order for you to control the flow of that particular burette masa you nak buat neutralization tu. Sebab I tak tahu your batch macam mana, your group macam mana, but from my previous experience, selalunya student ni when you want to perform titration, you perlukan sampai 3 orang to perform titration. Seorang nak control the flow, okay. Seorang nak tengok volume sodium hydroxide tu dah sampai mana. Seorang lagi nak goncang flask yang dekat bawah tu. Basically when you are performing titration, you just need one person je to perform that particular titration. Sebab nanti later when you go, when you join industry, jangan terkejut dekat industri pun sometimes memang you sendiri kena perform titration. You need to perform titration. Of course, if you join a big company, big industry, they will have this digitalized to measure the titratable acidity. Tak perlulah you all nak pakai burette tu, tak perlu. Memang dia ada macam, kan you all pernah buat yang protein, tak pernah juga kan. Dia akan ada satu bekas letak solution yang you nak neutralize tu together with your test sample. Nanti that particular equipment dia akan automatic keluarkan the discharge solution in order to neutralize. But that one is automatic lah. Of course when we talk about digitalization, automation, this one maksudnya mahal. Jadi tak banyak company yang want to spend their money for that particular high-end equipment or instrument. unless if let's say they are really particular about taking care of their data, the result, then they want to have a very accurate value, then they will purchase this particular high-end equipment or instrument. Okay, boleh tengok dekat YouTube how to measure pH. Kalau tak ada, you don't have the experience to hands on. Tapi I can assure you when you come back to UiTM, when the situation allow, when you come back to UiTM, it's a very simple procedure. Okay, senang je. You submerge dekat dalam solution, tekan read, okay, that's the result, yang itu you terus record. Alright, so now let's move on to chapter 5 for pH and acidity. Okay, for chapter learning outcome, for this particular chapter 5, the students should be able to define the importance of pH and acidity for food quality control. Okay, and then identify different types of acid. We have only 2 types of acid, and then method of measurement for acidity. Okay, this particular pH and total titratable acidity is very important for us because different pH, different total titratable acidity, it will give different outcome in terms of the quality for the product, in terms of the shelf life, in terms of the appearance, the texture, the color, and then the overall acceptability for that particular product. So itulah, the best is you know how to perform this particular testing, and you need to know why it is important for us to know about the pH as well as the acidity. Okay, so the first thing first, kita go with the pH first. pH. Okay, selalu kita tengok pH. pH tu apa pH? Okay, yang ini sepatutnya dah belajar juga dalam you punya chemistry. Tapi tak apalah, kita just buat macam refreshment course je lah for this one. Okay, pH, the letter of pH. Okay, this one is another thing. I just want to stress on this thing. Walaupun nampak kecil, okay, walaupun you rasa macam this one is insignificant, tapi the way you write pH must be in a proper manner. Okay, memang selalu bila you nak tulis pH, katalah the word of pH is at the starting of the sentence. Your computer ke, you punya handphone ke, dia akan buat autocorrect whereby the P dia akan capitalize. Okay, tapi when you want to write pH, please make sure that you know that the proper writing for the pH term, it starts with small case of P, capital case of H. Dalam hati you memang tahu pun, dah lama dah tahu daripada sekolah. Tapi bila you punya report, memang you akan tulis sama ada PH tu dua-dua huruf kecil ataupun P tu start huruf besar, H kecil. So tak boleh. The proper way to write PH is like this. Okay, memang P is small case, H is capital case. That is the first thing yang I selalu jumpa untuk students when they write about PH. Walaupun nampak kecil, but actually it gives a strong impact that you do not really well versed about certain terms, how to write a proper terms for scientific punya terminology. Okay, itu satu je lah. Not a big issue, tapi bila you join, bila you kerja, you masuk industri pun, kalau you salah tulis PH pun nanti orang akan apa ni? PH apa? Philippines ke? Apa ke? No. PH is PH. That is how it is written. Okay, so the letter of PH stands for power of hydrogen, whereby PH, power of hydrogen. Okay, whereby it is a figure to express whether that particular food product is acid ataupun alkaline solution, or it can be neutral. So nampaknya tadi kan saya ada mention yang pasal test strip tu kan? Test strip tu dia memang akan ikut color, this kind of color. Okay, kenapa tadi saya mention about green color? Green color when the chlorinated water is being used. Okay, contoh contoh apa chlorinated water is being used is to wash for vegetables. when you go for industry, when you join industry, especially those involving with the catering ataupun canning of the vegetables, of fruits, sometimes they will wash the vegetables and fruits by using chlorinated water. Okay, chlorinated water tu untuk apa? Untuk remove pesticide residue, to remove dirt, soil and etc. Alright, bila kita dah clean up dengan chlorinated water, of course after that it will follow with rinsing. Rinsing with clear water. Maksudnya rinsing tu air, the water for rinsing is not having any chlorine. Okay. Okay, when we rinse, we want to remove the residue of chlorine from that particular vegetables, from that particular fruits. Jadi selepas rinsing, okay, QA, QC ataupun production people, biasanya memang they all akan ada this particular test strip. Apa yang they all akan buat, they will check on the on the leaf of vegetable tu, they all akan check pakai test strip tu. Sebab sayur tu kan macam still basah juga kan on the leaf tu. Jadi dia akan letak test strip tu dekat sayur and then lepas tu nanti test strip tu akan bagi colour. Kalau colour dia green, neutral, maksudnya sayur tu, that leafy vegetables or that particular fruit is already free from chlorine. Okay, tapi kalau katalah colour dia still yellow, it give yellow ataupun dull green colour, contoh macam pH 4, nampak each colour they represent a certain a specific pH number. Okay, so kalau katalah colour dia masih lagi colour macam this one, olive green, so maksudnya there's still a residue of chlorine, chlorine sepatutnya, chlorine bukan acidic, chlorine patutnya this one, alkaline. Okay, contoh katalah colour biru okay, jadi when you have this kind of colour ataupun you have colour 9 lah contoh, slightly blue green colour, so you immediately can know that there is some chlorine residue left on the surface of the vegetable. So what you need to do in order for you to remove the chlorine residue? Ini soalan saya. What will you do? What will you suggest in order to remove the chlorine residue? No answer? Nanti kalau orang production people tu tanya dekat you, dia all dah test pakai test strip. Oh, dia kata warna dia still macam warna nombor 9 ni. Nak buat macam mana sayur ni? So apa ya? What will you suggest? Tambah acid. Jangan tambah acid. Okay, tak apa. One answer lagi.
Basuh lagi.
Betul. Basuh lagi sekali. Rinse one more time. Kalau you tambah acid, nanti sekarang you introduce acid pula dekat sayur tu. Dah jadi warna dia warna merah sekejap gini. Test strip tu warna merah. Okay, tak boleh. So apa yang kita buat, a simple solution je. Sorry, I memang suka tanya you all supaya you all boleh try to think what will be the solution that you need to come out. Because bila you masuk dalam industri later, katalah you have your, actually joining industry, food industry is very interesting because you can see that selama ni you makan food product macam ni rupanya processing dia, macam ni nak maintain in terms of the quality. But then when you join the industry, you need to think very fast and you need to think logically, rationally, and of course you need to give the best decision, the correct decision. Because selalunya orang when you join QA QC, so for production basically they are hoping that you have a suggestion of solution how to solve certain problem. Jadi katakanlah macam soalan tadi saya bagi dekat you, test strip tu still showing around number 9. Contoh is still macam a bit alkaline. When it is a bit alkaline, maksudnya there's still some chlorine residue left on the leaf of vegetable. So it is unacceptable untuk this particular leaf vegetable to be transferred to the kitchen untuk masak. Okay, sebab ada chlorine lagi. So it is not good. So nanti orang production tu tanya, then macam mana nak buat? Okay, so you kena bagi jawapan yang cepat dan tepat. So sometimes the decision supposed to be rather simple jugalah. You jangan fikir terlalu complicated sebab dalam production pun as much as possible we try to simplify things. Okay, so the answer is kita rinse lagi sekali dengan air. Okay, so katalah tadi the first time rinsing chlorine is not clear kan. So rinse lagi sekali second time. So second time you rinse you dapat colour dia around 8. Okay, so maybe you feel macam uncomfortable, then you can suggest to the production that they can rinse one more time so that you can achieve number 7. Okay, jangan tambah acid jangan kita kalau boleh kita try to not add more problem to in order for us to get the solution. Tak salah, betul juga sebab itu how you think, but you kena belajar how to solve the problem. Okay, itu apa yang sebelum ni lah, apa yang I share with my students, because later nanti bila you join industry orang akan tanya you. Contohnya you over the phone ada problem ni dengan production, so production akan tanya you, so apa nak buat ni over the phone. You kena bagi solution tu cepat tau, and it must be logical and it must be able to be execute by the production. So itulah, bukannya setakat belajar. Kalau dengan saya lah, sorry kalau dengan lecturer lain I tak tahu, tapi kalau dengan saya I try to jog your mind, okay, untuk fikir macam mana nak solve the problem. Okay, about this about the solve problem, I owe you all explanation relating to last Monday punya kelas kan. Related to apa? Rejection of the material ataupun finished product. Okay, we go back untuk production ataupun dalam industri. Okay, it is not easy to reject any material. Memang cara saya cakap dalam online lecture ni macam saya kata, okay, kalau it is when you conduct sampling, the defectives is more than acceptable value, kita kena reject the whole lot. Theoretically is correct. Secara teori memang betul. Tapi bila when you go for practicality, okay, before you reject any material, you need to check on several things. Okay, it is not as simple as bila dah sampai tak achieve to your standard, okay, reject, semua ni reject, bawa balik. Tak boleh it's not like that. Okay, when you came to a decision that this particular lot, okay, the delivery from that particular truck is supposed to be rejected, you kena check on several aspect. Okay, contoh dia, satu, you kena check on production side, bahagian production. Production untuk raw material ni, okay, contoh kita ambil raw material milk powder, susu tepung. Okay, katalah untuk nak buat ice cream ke, so milk powder is heavily used. Alright, tapi bila the delivery, today punya delivery ada defective and you supposed to reject that particular lot. Okay, but sebelum you reject, you kena check on several aspect. The first one, bahagian production. Do they have enough milk powder ataupun raw material that they are going to use for the incoming production, for the upcoming production? Okay, kena check dekat bahagian production. Check dekat bahagian production tu, you kena call lah. Contohnya if let's say you are the executive, QEC executive, then you need to contact to the respective production executive, minta dia worker dia ataupun staff dia or dia punya supervisor pergi check. Ada cukup tak material ni, because now we are having issue to reject this particular container ataupun this particular delivery. So nanti selalunya memang they all akan give cooperation lah that is based on my experience. I do not know some company I heard it is quite difficult to get cooperation, tapi mungkin bergantung kepada cara you minta tolong, you tanya tu macam mana. You tak boleh jadi bossy, oh sebab you control the QAQC, you rasa macam you punya level atas sikit daripada they all. No, basically you are the same. Sometimes it is better for you to talk properly to them so that they can execute. Tujuannya untuk apa? Untuk they all buat apa yang kita nak buat. Okay, kena cakap elok-elok. Okay, so selalunya kita akan tanya dulu production, do they have enough of this raw material in their capacity, in their storage area? Okay, warehouse adalah tempat untuk kita nak store semua incoming raw material ataupun finished product. Tapi untuk production pun, they will have their own small storage area for the raw material ataupun finished product yang raw material yang they all nak guna ataupun finished product yang baru completed, that is just completed. Okay, so basically production they have their own storage area as well. Warehouse pun ada, warehouse tu lagi besar lah, production punya tu kecil saja. Jadi kita akan tanya production, do they have enough of this raw material? Kalau production kata okay cukup untuk sampai production esok, dia kata. Tapi after that tak cukup dah, dia kata. So we need this raw material urgently. Okay, so itu satu. Dah check dekat bahagian production. So you check pula dekat bahagian warehouse. Selalunya dalam industri kita tak akan beli raw material tu cukup-cukup je untuk pakai. No, kita akan ada backup untuk each raw material. Maksudnya bukan backup, kita akan ada extra quantity of that particular raw material, each material. Sebab kita we need to take precaution for this particular situation lah Okay, so dah check dekat production, dia kata dia ada cukup sampai esok. Okay, tu satu. Second one, kena check juga dekat warehouse. Warehouse ada tak this particular raw material? Kalau ada berapa? How many tons? How many kilograms? Okay, kalau warehouse kata okay they all ada. Contohnya they have around 50 cartons, 50 kotak. 50 kotak katalah satu kotak 10 kilogram. 10 kilogram kali 50 jadi berapa? 500 kan? Betul tak? 500 kilogram. Betul ke tak betul saya kira? Betul kan? Okay, so 500 kilogram of milk powder. Okay, nampak Tadi kita dah check dengan production. Okay, ni kita check dengan warehouse. Dia kata dalam warehouse, in warehouse keeping, the storage in warehouse ada 500 kilogram of milk powder. Okay, 50 carton 10 kg of milk powder. Okay, so apa nak buat? Okay, this number ni, tadi yang kita kira 500 kilograms tu, this number ni kita tanya balik dekat production. Okay, warehouse ada 500 kilogram milk powder. Kalau nak run untuk production cukup sampai berapa hari? Production akan bagi feedback. Dia kata, oh okay, kalau 500 kilogram cukup lagi 2 hari contoh Cukup lagi 2 hari. Lepas tu baru you boleh buat decision to reject the whole delivery. Okay, itu situation yang maksudnya everyone is having their own keeping of that particular raw material. Katakanlah tak cukup, production kata, oh yang ini cukup untuk hari ini je. Dekat warehouse kata, no, kita hanya ada 20 kg sahaja. Bila jadi macam ni, you tak boleh reject the whole lot. Ataupun, you nak reject the whole lot, contoh, you need to make sure that purchasing department make an urgent arrangement to replace this delivery secepat mungkin sebab we are running out of this particular raw material. And dalam industri kita tak boleh running out of any raw material. We cannot at all, at any cost cannot, because when we running out even one raw material, contohnya katalah garam tak ada. Dia kata apa, susah beli je lah garam dekat Giant. Dekat industri kita tak pakai garam 100 gram, 200 gram. No, kita pakai a few kilos of salt, a few hundred kilos of flour. Kita tak pakai paket kecil-kecil yang kita beli kat Giant tu, no. Jadi dalam industri tak boleh ada shortage, tak boleh ada shortage of any raw material. Sebab when we have shortage of raw material, what will happen to the production? In your opinion, what will happen to the production when we running out one raw material?
Production
Akan
kena stop.
delay untuk certain produk.
Bukan lagi delay, production stop terus. Bila production stop, what happened to your product? Tak ada produk. Tak ada produk, tak boleh hantar keluar ke market. Then suddenly orang kata, kenapa tak ada, contohnya macam apa, roti lah hari tu yang masa PKP kan ada isu roti apa benda, orang berebut roti macam apa tak sangat. Jadi macam bila tak ada produk tu dekat market, dia akan jadi customer ingat macam kenapa tak ada produk ni hari ni dekat market. Dia all dah berhenti buat produk ke? Oh tak apalah, kita tukar produk lain, kita tukar brand lain. Nampak So it is a ripple effect. Disebabkan satu saja raw material, kesan tu dia akan jadi makin banyak. Jadi customer tu dia kata, hari ni tak ada tak ada produk daripada company A. Kita tukarlah beli daripada company B sebab company A tak ada produk dia. Okay, so that's why kalau you all tengok kan yang masa isu yang PKP tu, Gardenia tu sampai merayu dekat orang, don't hoard, jangan bergaduh, jangan beli melebihi kapasiti roti sebab they already produce 1 million, 1 million per day. That one is not a surprising numbers to me because it's very common dekat dalam industri, memang kita produce banyak. Okay, alright. Kalau katalah yang itu kalau kata datang dalam truck tau, dalam tanker. Contoh tanker, susahlah kita nak asingkan mana yang okey, mana yang tak okey. Kalau katalah raw material tu datang dalam carton box, dalam kotak-kotak, that one senang sebab kita boleh conduct 100% checking. Okay, remember I ada mention dekat you pasal 100% checking. Kita boleh buat 100% checking, maksudnya kita boleh asingkan mana yang okey, kita letak ke tepi, kita boleh ambil untuk warehouse kita simpan. Mana yang tak okey kita hantar balik kepada truck. Itu kalau that situation will only be done bila kita ada problem shortage of raw material. Kalau kita tak ada shortage of raw material, then it should be fine. Kita boleh reject the whole truck and minta that particular truck untuk hantar replacement. Tapi just so you know, just nak bagi tahu dekat you all lah, bila you all reject ni sebenarnya orang purchasing tak suka untuk you all reject raw material. Sebab bila you all reject raw material, maksudnya akan tambah kerja bahagian dia. Dia kena contact supplier, dia kena buat arrangement lain untuk delivery of the raw material, and then manpower dia lagi, there's a lot of things. Okay, jadi walaupun cara saya cakap kata this one kena reject, this type of quality attributes tak acceptable dan kena reject, it's not really the case. Memang secara teori, cara bercakap tu nampak senang, tapi bila you join industri nanti, there will be several aspect that you need to think of. Okay, alright, so I hope I answer your question. Lama pula saya menjawab soalan sampai setengah jam. Okay, alright, so we go back to this pH. It is a logarithmic scale whereby the value of 7 is considered as neutral, and then 14 is alkaline, 1 is very acidic, ataupun it can goes to 0, 0.1, 0.2. And memang boleh pH meter, some of pH meter they are very sensitive, and this one will be quite high end juga untuk pH meter if they are able to measure up until 2 scale macam 0.01 contoh the pH of that particular solution 0.01, maksudnya that particular pH meter is very accurate. Okay, kalau katalah setakat dia tunjuk 1, 2, 3, that one is kita tak tahu in between 1 tu berapa value after that, 1 point berapa, 1.1 ke, 1.5 ke, 1.45 ke. So the best one to get pH meter is the one that is accurate, that can give you accurate number. Okay, so the pH is equal to -log 10 C, whereby C is the hydrogen ion concentration in moles per liter of water. Alright, so to understand more about pH, the chemistry of water need to be known, whereby the molecule of water is composed of two molecules, two atoms. Three atoms. One is oxygen atom and the other one is two hydrogen atom. So we have this majority semua orang tahu how to write the water formulation is H2O. Okay, 2 ni sepatutnya bukan besar, kecil, H2O. Okay, and then for pure water ni apa maksud dia? Pure water ni contoh distilled water, deionized water. Okay, kalau you all tengok dekat market, we have distilled water, drinking water, mineral water. Distilled water, this one it is also known as pure water. Pure water maksudnya the ratio between acid dengan base tu maksudnya alkali lah, it is in equilibrium. Okay, tapi when we talk about mineral water, dalam mineral water ada mineral, so the name is mineral water. Jadi ada mineral. So of course when we talk about mineral water, the pH is not similar like pure water. Pure water pH sepatutnya pH 7. Okay, because this particular water molecules, okay, kalau tengok dekat bahagian bawah ni, dia punya ion, okay, ion, acid ion dengan basis ion, okay, basis ion is in equilibrium, sama. Jadi that's why when we check with pH meter, the pH of this particular pure water supposed to be pH at 7. Tapi when you talk about drinking water or mineral water, this particular ion, acid ion, bases is not really in equilibrium because the presence of some minerals and other types of compound. Okay. However, a very small amount of them will react with each other in the following manner. Jadi untuk water ni, dalam water tu sendiri, okay, they will associate and reassociate among themselves, whereby it becomes hydronium ion as well as hydroxyl ion. But of course, they are existing in equilibrium. Okay. So hydronium ion is the chemical unit which accounted for the acidic properties of solution. Contohnya bila you masukkan macam orange juice contohnya. Kan orange juice, nama juice. Juice tu maksudnya ada solution, water, acidic. Jadi that particular H tu yang contribute towards the acidic part. Okay, pH tu more acidic. Tapi when we have this hydroxyl ion, okay, the bases, this particular OH, this one contributed for the alkalinity of a solution. Contohnya if let's say you are doing sodium hydroxide solution. So sodium hydroxide dia punya chemical formula is NaOH kan, sodium hydroxide. So that particular OH is responsible for the alkalinity for that particular solution. And when pure water reacts, it produces equal amount of hydronium ion. Okay, this one H3O, this one is hydronium ion as well as hydroxyl ion. Okay. It will not have any excess of either ion. So that's why it is known as neutral solution and the pH is supposed to be at pH 7. Okay, contoh if let's say kita guna strong acid, for example hydrochloric acid, and then we add to water, then we have some reaction whereby this particular HCl, dia akan reassociate with water H2O whereby it will produce hydronium ion and then dia akan ada chlorine dekat situ. Okay, then the addition of HCl to water will increase the H3O, the hydronium ion or the acid concentration of the resulting solution. So that's why it becomes more acidic. But when we add with sodium hydroxide is more towards base. Kita ada OH dekat sini. So when they are being added to water, dia akan separate. It becomes sodium as well as OH. Okay, so the addition of sodium hydroxide to water will increase the hydroxyl or alkaline concentration of the resulting solution. Okay, so another interesting aspect of water is whereby this particular hydronium ion as well as hydroxyl ion, basically they try as much as possible to remain in balance. Equilibrium tu in balance lah in terms of the amount is in equilibrium. So an increase in the concentration of hydronium ion will cause a proportional decrease for the concentration of OH, okay, hydroxyl. Maksudnya bila kita tambah asid, hydroxyl ion akan naik, tapi hydronium ion akan naik, tapi hydroxyl ion akan turun. Alright, so basically there is a table whereby it shows the logarithmic relationship between the hydronium as well as hydroxyl ion. But I don't think we have that table in your, it's here. Okay, this particular pH scale is a more, we can say is more accurate to quantitatively expressing the acidity of a solution. Okay, when we talk about acid, okay, contohnya the pH is 1, meaning that it is having a 1 million times more of hydronium ion compared to hydroxyl ion. Okay, so this one, it shows the schematic diagram for the pH that is having more hydrogen ion compared to hydroxyl ion. Alright, so now we move on to types of acid. Okay, for types of acid, we have two types of acid. One is organic acid, the other one is inorganic acid. Okay, organic acid, this one to simplify your understanding, organic acid is basically the one that is naturally occurring in food products. Inorganic acid, it is being synthetically produced ataupun man-made ataupun they are being produced in the lab. Okay, so for inorganic acid, contoh kita ada hydrochloric acid, sulfuric acid, phosphoric acid and nitric acid. Okay, these are the acids lah. Sulfuric acid ni tak tahulah you have encounter with concentrated sulfuric acid dengan concentrated HCl, but then this particular acid, inorganic acid, they are very dangerous because they are corrosive. Yang ni you all tahu kan, they are very corrosive, dangerous, and some of them are very highly flammable. Maksudnya dia mudah terbakar. Because kalau you pernah encounter dengan contoh, if you encounter with hydrochloric acid, concentrated hydrochloric acid, yang ini sepatutnya botol dia ni kaca, glass. Sepatutnya mesti dalam glass. When we talk about acid, basically the best storage container will be in glass because glass is inert. Dia takkan ada relationship, dia takkan ada reaction with the acids. Okay, so bila you open up this bottle, selalunya bila kita nak buka the opening of the bottle, normally it needs to be done in fume hood, in fume cupboard, dalam kebut wasap, in fume cupboard. Because when we open up, there will be fume coming out from this particular concentrated acid. And this particular fume is toxic to be inhaled by human ataupun animal lah. Jadi that's why kita akan buka when we want to open up this type of acid, concentrated acid, kita akan masukkan dalam fume cupboard, switch on, dan baru we open up the opening of that particular bottle. Sebab the smell needs to be eliminated. Kita as much as possible we try not to inhale the fume. And it is corrosive, betul ataupun tak, memang betul, sangat korosif. Because contoh macam you deal dengan orange lah kan, orange daripada buah orange tu, you kena you squeeze air orange tu, you rasa sakit tak dekat tangan you? Tak rasa apa kan? Okay, this one is my personal experience as well. Masa tu I buat degree lah. Degree ke master? Masa tu I buat masters. I tengah buat crude fiber. Have you have any experience performing food analysis for crude fiber? Tak ada juga. Tak ada. Ada ke tak ada?
Ada madam part 3.
Ada
Practical.
madam SEM 3.
Ada.
Oh ada, okay, so sempat lah. Okay, remember tak bila buat crude fiber kan you kena pakai sodium hydroxide dengan you kena pakai hydrochloric acid ke sulfuric acid Sulfuric acid tak silap saya.
Sulfuric acid.
Sulfuric acid kan. Tapi yang you all buat dekat lab tu you all tak guna condenser, am I right? You don't use any condenser if I'm not mistaken.
Tak.
Betul tak? You all just boil atas hot plate saja, betul tak?
Betul.
And lepas tu dapat result crude fiber you beratus-ratus ataupun negatif. Betul tak?
Dapat
Okay,
sikit.
sepatutnya.
Dapat sikit
Betul tak?
gila dia punya fiber.
Whereby contoh macam katalah katalah high fiber cracker lah contoh kan, tapi you dapat 0.00 something which is illogically tak sepatutnya dapat that kind of ni, because one of the method, I mean the procedure tu bukan salah, cara teknik tu salah, kena ada condenser. Okay, so kalau you all nantilah if you got time you can watch on the YouTube how to perform crude fiber analysis. Sepatutnya kena ada condenser. Dia punya setting up dia sama macam you buat SOX-SLAT tu, yang fat analysis by SOX-SLAT method tu. Remember tak SOX-SLAT?
Ingat, madam.
Tapi SOX-SLAT untuk fat dia kena ada yang siphoning process tu kan. Tapi untuk crude fiber tak ada yang siphon tu, tak ada. Kiranya terus you punya flask attach dengan condenser, dan condenser tu sebab kita nak cool down the water lah. Okay. To cool down the ni. During boiling process tu kita nak cool down yang fume tu. Okay, so what happened during my time tu, masa saya buat, sebab kita kena pakai sulfuric acid tak silap saya. Okay, sulfuric acid tu kita pakai condenser, dan masa tu mungkin I tak letak anti-bumping. So what happened was that during boiling process tu, that solution dia macam erupted daripada flask tu, naik condenser, terkena dekat saya punya tangan. Okay, but then untuk crude fiber tu dia punya sulfuric acid not really concentrated lah, but it's quite concentrated but not really concentrated. What I mean when concentrated meaning it is directly from the bottle itself. So kena saya punya tangan. So masa tu tak rasa apa, it hit to my thumb. So during that time I tak rasa apa, tak rasa sakit. But the next day memanglah dia rasa pedih sikit lah sebab kena acid. Then after that of course we knew when you kena strong acid ke strong alkali ke, the first thing what you need to do is you need to wash with a lot of water. So masa tu I wash with a lot of water. I wash, then the next day what happened was I perasan I punya thumb tu dah jadi berlekuk. Maksudnya dia already corrode my thumb. I masa tu rasa macam sedihnya, my thumb dia dah jadi berlubang sikit because of that crude fiber analysis. So is it corrosive? Yes, it is corrosive. You all takkan rasa apa, because I noticed in my previous experience, student bila they deal with strong alkali ataupun strong acid, they all rasa tak ada apa. So tak nak buat dekat dalam fume cupboard, tak ada precaution, tak pakai glove, tak pakai yang mask, N95 punya mask tu, because you don't have that experience of kena this strong acid or strong alkali. So during that time my thumb tu quite berlekuk lah. Tapi over the years alhamdulillah lah ada regeneration of skin cells, so it goes back to normal. And then another thing, my friend, sorry ni I cerita pula because I nak bagi tahu dekat you all why this particular inorganic acid is very dangerous. Yang itu dia buat protein. Protein memang pakai concentrated HCl if I'm not mistaken. HCl ke? HCl. So during that time tu, masa yang digestion process tu, kan pakai HCl kan nak digest. Tak tahulah macam mana tiba-tiba meletuplah benda tu, and my friend tu dia masuk dalam lab tak pakai covered shoes. You kalau nak pakai covered shoes pun as much as possible avoid pakai yang kain punya. So my friend tu dia tak pakai covered shoes, dia pakai sandal. Orang perempuan kan pakai sandal biasa je. Jadi bila benda tu meletup terkena dekat dia punya kaki, kaki dia pun swollen, quite huge jugalah swollen because kena acid. Okay, so next time if let's say you have your you have your opportunity to come back to UiTM, or you are going to deal with this inorganic acid, please take extra precaution because it is dangerous. Okay, and then when we talk about organic acid, this one is not as strong as inorganic acid. Contohnya we have this citric acid from citrus fruit. That's why the name citric acid from citrus fruit. And then we have this vinegar. Okay, vinegar ni ada acetic acid. And then we have this formic acid. This one is known as weak acid lah. Okay, so acids, they are molecules whereby they are being made up of at least two atoms. One is hydrogen, which is known as cation, and the other one is anion. Okay, the other part of the acid molecule could be a single atom or consist of a large molecule with many atoms that is known as anion, whereby it is negatively charged. Cation, boleh tengok dalam gambar ni kan? Cantik dia orang letak gambar ni. Okay, cation is a positively charged, and anion is negatively charged. Okay, so we have this example just now from our previous slide. We have this formic acid. It is categorized as a weak acid, and basically when it is reassociate, sebenarnya it is having a formate ion. Okay, formate ion, this one is yang bahagian anion. Okay, anion, cation is a formic acid. Alright, and then we have this acetic acid. Okay, when it is achieved in equilibrium, basically we have this acetate ion together with acetic acid. Okay, so for organic acid, basically they are not going to dissociate completely. Maksudnya dia tak akan dissociate from its original formation when it is being introduced to water. They still have their own signature of their acid in water when this particular organic acid is being dissolved in water. So when this organic acid is being added into a solution, basically dalam water lah, we talk about water, distilled water, some anions, they will still hanging on to their hydrogen ion, as well as those that have split apart. So this particular organic acid, they are found in living things, for example in plants, in fruits, as well as beverages. And this particular acid, which have more than one hydrogen ion, and those acid will have anions whereby it has two hydrogen ion. Some of them will have one, some of them will have none of this hydrogen ion. So each of them will have a different dissociation curve. Okay, so anion, which is the part that gives the name of its acid. Okay, contohnya we have this malic acid, tartaric acid, acetic acid, and nitric acid. And this particular anion, it will have more than one hydrogen ion and an acid which may have hydrogen atoms in its anion. So when acid molecules are present in aqueous solution, such as water, wine, or beer, they can dissociate, whereby the anions and the hydrogen ion will be separated, but it is not fully dissociated, okay, for this particular organic acid. Okay, kita habiskan sampai inorganic acid. And inorganic acid, they are completely considered as strong acid because they can dissociate completely, okay, whereby all of their hydrogen ion will dissociate from their anion. Okay, hydrogen ion tu dia akan dissociate daripada anion. So contohnya macam HCl, when we add into water, dia akan dissociate to become hydronium ion, and then dia akan keluarkan dia punya anion. Okay, chlorine. Then we have this nitric acid, HNO3. Okay, when we add with water, so dia akan jadi hydronium ion as well as nitrate. Okay, then we have this sulfuric acid and ethanoic acid. Okay, so this one is the pH values of some common acids, bases, and other substances in food products. ini basically before ni I letak this one just a method for the students to just have a rough idea what's happening. I mean when we talk about organic and inorganic acid. So nampak when we talk about inorganic acid, hydrochloric acid, ini spelling ni nanti you all betul lah. Hydrochloric acid, nampak the pH is pH 1. And then sulfuric acid pun it's is having a low pH, pH 1.2. But then when we talk about lemon juice, okay, lemon juice it is from citric acid. It is considered as acidic juga. The pH is pH 2.0 and do you know that you can light up a bulb from lemon? Sodium bicarbonate, the pH is around 8.4 whereby for egg whites is in between 8 to 9 and then we have this ammonia. Nampak it's very strongly alkaline. Okay, then you have this pH value lah untuk selected foods. So, boleh tengok lah sendiri dekat sini. Kita ada for vegetables, for fruits, meat and poultry, dairy foods and fish as well as shellfish. Okay, ini kita discuss sikit before we end our class. Okay, acid alkaline diet concept. Have you heard about different types of diet program? We have this acid alkaline diet program. Kita ada based on blood type program, based on body shape program diet, macam-macam lah. Have you heard about those diet program?
Yes.
Okay, yang ini untuk acid alkaline diet ni you can read on your own lah. But this one will be my personal opinion lah. This is discussion whereby you can agree to disagree. Maybe you disagree with my opinion, but for my opinion, of course you ada juga dalam you punya slide ni ada acidic alkaline food comparison chart whereby you need to eat less acidic food, you need to eat more alkaline food ataupun neutral food. It is true because everything that you consume it must be in moderation. Okay, regardless whether it is acidic ataupun it is alkaline ataupun it's neutral, everything must be in moderation. But what makes it interesting for this particular slide whereby siapa yang prepare ni, Eddie ke Syarimi, I pun tak sure. When this Eddie ataupun Syarimi put this one debatable concept, this one is up to you as well. When we consume, contohnya I consume lemon. Lemon very acidic kan? pH dia pH 2 tadi. But when it enters into our system, our body system kita dia akan have a check and balance of pH in order for our body to perform at optimum rate. Okay, so kalau you eat more alkaline food, bila masuk dalam you punya digestive system, kan you punya digestive system is very acidic, you punya gastric juice tu very acidic kan. So your body will balance out balik the the food that you consume. Okay, so for me I tak tahulah, this one is up to you, but for me if let's say you are having you want to take care of your meal or your diet, everything must be taken in moderation, not too much, not too less in any classes group of food products, food hierarchy. Okay, alright, so I think that's it lah untuk hari ni. Kenapa yang saya cakap pasal acidic alkaline ni, because betul lah sometimes bila you dah tua kan, you akan ada that kind of effect tau. You tak boleh makan pedas sangat because your body cannot tolerate with those spiciness, with those acidic food product, because you akan ada heartburn lah whatever. Yang tu bila you dah tua lah, tapi bila you muda lagi is okay because your body basically at your age your body is performing at its optimum condition as long as you jaga you punya kesihatan lah, your health. Alright, So kalau nak suggest dekat orang pasal makanan, for example your family member sekarang kan duduk dekat rumah and orang pun ingat you ni macam doktor juga sebab you ambil food science and technology. So tanya, yang ni bagus tak nak makan? Yang ni okay tak? So everything must be taken in moderation. Alright. Okay, so before we end this class, do you have any question?
No.
Tak ada. Okay, nak habis cepat lah tu. Alright, so nanti you punya attendance tolong isi at 2 PM nanti. It is available insyaAllah at 2 PM sebab now dah pukul 1. I need to set up for my previous class sebelum kelas you all. I ada kelas sebelum ni. So insyaAllah by 2 PM your attendance should be available. So please fill up your attendance form dekat situ Okay. So kita akan sambung your lecture hari Isnin for PH and acidity. Alright, thank you for your attention. Thank you for your participation. I'll see you again next week. Alright, okay, thank you. You may leave the meeting.
Thank you, madam. Bye.
Thank you, madam.
Thank you.